Okay, so for width of a human hair, what I have is I have my laser on the stand. Again, I'm using red because it's the longest wavelength, which is the easiest thing to measure, except now the student should know the wavelength of red light. And then what happens is, I don't know if you can see that, but you can see the red light striking the human hair. So thank you to my wife for contributing that. I said to her, I need a human hair for a demonstration today. And she politely said, well, I'll leave some in the shower for you. Any case, so it's hard to see the diffraction taking place up on the screen. So what I'm going to do is I'm going to bring the camera much closer. And I don't know if you can see that. Let's turn off the rest of the lights in the classroom. Let's see if we can see that in the camera here. Okay, so you see the spot. And I believe you can see those maxima. You can see those bright maxima right there. So all I've got to do is measure the distance between some of the bright maxima. I would never measure the distance between two adjacent bright maxima. I would never do that. That's terribly imprecise. So I don't know if you can see me using this marker right here. What I'm going to do is I'm going to mark the center of one of the bright maxima. I'm going to mark the center of another bright maximum. And then I'm just going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 12 orders separated from each other. So those maxima are 12 orders separated from each other. And now what I'm going to do is I'm going to measure the distance between those two. Just going to measure the distance between those two. And it's 12 maxima apart, and it's about 12 centimeters. Isn't that nice? And then the distance between the hair, where the diffraction begins, and the screen, I'm just going to get that distance right now, and I get 1.42 meters. All right, so then from this, we can use this to measure the width of a human hair.